How's it going, guys? Today we're going to be going over the Algebra 2 review worksheet for test 4.1 to 4.4. So let's go ahead and get started. Number one, we're asking what the formula for the discriminant is. Remember, it's just b squared minus 4ac. Do not include the square root. We don't care about the square root. When we're asking for just the discriminant, we just want b squared minus 4ac. Okay, number two, I'm just going to do one or two of these. We're asked to simplify these. So I to the 6th, what you want to do is take the exponent, divide it by 4, and see what the remainder is. 6 divided by 4, 4 goes into 6 one time, that multiplies the 4, 6 minus 4 is 2. We stop here because all we have left is decimals, so that number that's left over is our remainder. So we have 1 remainder 2. So that remainder becomes our new exponent for I. So I to the 6th is the same thing as I squared, because we take this remainder and put it on top of I, and I squared is just -1, which is what our answer is. Okay? Same thing with B. We'll take 13, divided by 4. 4 goes into 13 3 times. 4 times 3 is 12. 13 minus 12 is 1. After that 1, all that's left are decimals, so we stop here. So we have 3 remainder 1. You take that remainder and put it on top of an I. So you have I13 is equal to our new I, which is I to the 1, which is just I. And that's where you stop. All right, so 3a, we're asking what -21 times I to the 6 is. We just solved for I to the 6 with 2a, sorry. So -21 times I to the 6, we solved I to the 6, we said that's -1. So we know -21 I to the 6 is the same thing as -21 times -1. -21 times -21 is just 21, right? And we got that I to the 6 from our problem 2a. For problem 3b, we're asking for 5i to the 13. On 2b, we solved I to the 13, we solved it through speed I. So we can go ahead and replace 5i to the 13. Let's just divide that up a little bit. So we know 5i to the 13 is going to be the same thing as 5i to the 1st, or just 5i. All right. So let's keep going. Number 4, we're asking you to rationalize each of the following expressions. Remember, you cannot have a square root on the denominator. So when we're asking to rationalize it, we're asking you to get rid of that square root in the bottom. All right, and we need to get rid of the square root in the bottom. What we're going to do is multiply the top and the bottom by the square root of the bottom. All right, so we're going to multiply this by root 10 all over root 10. It's okay for us to do this since root 10 divided by root 10 is still 1, so we're not changing the value of the fraction. So this will equal 11 root 10 all over root 10 times root 10 is the same thing as just 10, right? You multiply two square roots or two congruent square roots. All you do is get rid of the square root. So 11 over root 10 can be rationalized to 11 root 10 all over 10. All right, so for 5, we're going to do the same thing. Multiply it with root 3 over root 3, and we get 12 root 3 all over 3. And we see that 12 and 3 can actually reduce. So you can simplify. You have to simplify. So 12 divided by 3 will just give us a 4 root 3. All right, so let's keep going. We're down for number 8 now. We need to solve each of the following quadratic equations. So we only have one kind of x term over here. We don't have a bx. Our b equals 0 in this problem. So we don't have to use the quadratic equation or completing the square. You could. You're going to be wasting a lot of your time, and there's much easier ways to do it. So what we're going to do with this, we're going to isolate the x value. So minus 225 on both sides. So we get 16x squared equals negative 225. Then we're going to divide by 16. And we get x squared equals negative 225 all over 16. You do not have to change this to a decimal, and you can't reduce this anymore. And remember, if you take a square root of a fraction, you actually can distribute that square root to the top and the bottom. So if we're taking the square root of this x, the x squared term over here, we're taking the square root of the right side as well. We're left with x equals plus or minus the square root of negative 225 all over the square root of 16. Right? You can distribute that square root to the top and the bottom of a fraction. And also do not forget that plus or minus, since we are taking the square root of a variable, and if you take a square root of a variable, you have to account for both numbers, the positive and the negative version. Okay? So your x equals plus or minus the square root of negative 225 all over the square root of 16. The square root of negative 225 is 15i. Since the square root of 225 is 15, you get the square root of a negative 1 in there as well, which is I. So our answer is x equals plus or minus 15i, and the square root of 16 is just 4, and that's what we get. X equals plus or minus 15i all over 4. Let's keep going. We're asked to find the square of each imaginary number, and when we say find the square, we're asking you to square the imaginary number. We're asking you to square it. When we say square, that means raise it to the second power or multiply it by itself. So negative I root 7 squared gives us negative I root 7 multiplied with negative I root 7. So we're multiplying these numbers like this together. You need to multiply the coefficients together. So negative I times negative I gives you a positive I squared. And multiply the square roots together. Root 7 times root 7 just gives you a positive 7. I squared is negative 1. So you get negative 1 times 7, or just negative 7 for number 11. And you'll do similarly, you do the same thing for 12, 13, and 14. Going on, we're asked to simplify each of the following expressions. So on number 15 and 16, we're adding complex numbers. So 8 plus 5 gives you 13, and 2 plus 6i, or 2i plus 6i, sorry, gives us 8i. Okay? And that's what we have. That's where our answer is. Just add like terms. Do not distribute when you're adding. It's only for multiplication. When you're adding or subtracting, all you're doing is combining like terms. That's it. For number 16, we're doing the same thing. 8 plus 5 gives us 13. Negative 2i plus negative 6i gives us negative 8i for our answer. For 17, we have a negative. There's two ways to do this. I'm going to do them both ways. The first one, what you could do is just subtract normally. So you have 8 minus 5, which is just 3. Then negative 2i minus negative 6i gives you a positive 4i, right? You have negative 2i minus a negative 6i. You change the sign and add a line. You get negative 2i plus 6i, or just positive 4i. Another way to do it, I'm going to do it with number 18, is you can take this negative right here and distribute it, and then just add like terms. So you have 8 plus 2i. Distribute that negative, you get negative 5, and minus 6i when you distribute the negative to the other parentheses. We're going to go ahead and add like terms. So we have 8 and negative 5. It gives us a positive 3, and 2i and minus 6i, or minus 4i. All right. Also, please be mindful that you're putting these in a plus bi form. If you're not putting in a plus bi form, you're going to get the answer wrong. It has to be in this form, or it's not correct. All right, so now we're asked to find all the solutions of the equation x squared minus 13 equals 612, and we're going to circle our answers. So we see we still only have one x term, the x squared, and we have two constants, negative 13 and 612. So what we're going to do is isolate the x again. So we're going to add 13 to both sides, and we get x squared equals 625. And then once we have our x squared, have our x term isolated, what we're going to do is take the square root of it, and we get x equals plus or minus the square root of 625. The square root of 625 is just 25. So we get x equals plus or minus 25. Remember, you take a square root of a variable, you have to account for the negative version of it as well. Okay? So you get x equals plus or minus 25. That's number 1 and number 4. There's no negatives in this answer, so, or no negatives underneath the square root, so we do not have any i's. So our answer is just 1 and 4. And you do the same thing for number 20 as well. I'll leave that for you guys. All right, number 21, we're asked to state whether the solutions are real or non-real. Remember, if we just want to know the properties of the solutions, all you need to know is a discriminant. If you want to know how many solutions and if it's real or non-real, all you need is the discriminant. All right, so A equals 4, B equals -5, and C equals -13 for number 25. So remember the discriminant is B squared minus 4AC. So we're going to go ahead and plug that in. B squared gives us 25, and we're going to minus it with 4AC. So 4 times 4 is 16, and then 16 times -13. Right? So 16 times 13, or -13, sorry, gives us a -208. So you have 25 minus -208, or 25 plus 208, which gives us 233. So our discriminant is 233. Okay, so we see our discriminant is positive, and if it's positive, that means we have 2 solutions. It's non-zero, so we have 2 solutions. And we also know it's real since it's positive. Because remember, ultimately, we're going to be taking the square root of the discriminant. So as long as the discriminant is positive, our answers will be real. And you do the same thing for number 22. Figure out your A, B, and C, and plug it into the discriminant formula. All right, same thing with 23 and 24 as well. We'll leave that for you guys. And we're going to go on to number 28. So we're multiplying complex numbers now. So when we're multiplying complex numbers, this is where we actually have to distribute. All right, so for number 28, we're going to take that -2, multiply it with the 6, so we get -12, and the -2 with the I, so we get -2I. And then we're taking that 3I and multiply it with 6, which gives us plus 18I. And then take that 3I and multiply it with the I, and that gives us positive 3I squared. We're going to add like terms. -12 is going to bring it down for right now. -2I plus 18I gives us a positive 16I, and 3I squared gives us a -3I. Right? I squared equals -1. -1 times positive 3 gives us a -3. And now we can see we can add this -3 and this -12 to give us -15 plus 16I. And that's what our answer will be. You do the same thing for 29 and 30. The biggest thing to remember is that when you have the I squared, you have to convert it to -1 and simplify from there. If you give an answer with I squared, the answer is not going to be correct. Okay? So 29 and 30, I'll leave that for you guys. Now for 31, which of the following belongs to a set of complex numbers? If you guys remember, complex numbers includes all real numbers as well. And that's because for numbers like 17, is the same thing as 17 plus 0I. This is the imaginary part, so it's technically still a complex number. So every real number is still a complex number. So in this case, all of these are complex numbers. All right, number 32, we're given the graph of the inequality, 1/3 times x plus 5 times x plus 1, that's less than 0, and we're going to state the solution in set and interval notation. Okay, so when we say we want everything underneath 0, or sorry, less than 0, that means we want everything underneath the y equals 0 line, right? So everything below it, but not including the green line. All right, so that means we want this red part right here. That's what our solution is going to be, and we need to put that in set notation and interval notation. Okay, so in set notation, we know this is going to be x such that x will have to be greater than -5 right over here. It has to be greater than this, and it has to be less than -1, right? It has to be to the right of x equals -5, and has to be to the left of x equals -1. So x has to be greater than -5, and it has to be less than -1. And for interval notation, we can say that's going to be a soft parentheses from -5 up to -1. We're using parentheses or soft brackets, whatever you want to call it. We're using those because we're not including the green line. We just want strictly what's below it, below the green line. So from -5 to -1. Number 33 will be very, very similar. Draw your line, mark where your solution is going to be, and put it in set and interval notation. Okay. The more you mark your graph, the better chance you'll have of getting it correct. So please do so if you can. Number 34, we're told a ball is still in the air with an initial vertical velocity of 14 meters per second from an initial height of 5 meters. The ball's height h in meters at time t in seconds can be modeled by the quadratic function. H of t equals -4.9 t squared plus 14t plus 5. We're asked, does the ball reach a height of 16 meters? If we're only asked, does the ball reach a height of 16 meters, we're not asking when it reaches the height. Remember, we don't need the solution. All we need is the discriminant, because the discriminant will tell us if the height actually exists or not. All right, so our h of t in this problem is going to be 16. And we're going to go ahead and plug that 16 back into our quadratic function and get a new quadratic function that we're going to use to figure out what our discriminant is. So we have 16. That equals -4.9 t squared plus 14t plus 5. We're going to minus 16 because remember, if you do not have a 0 on one side of the quadratic, it's not going to work. So we have 0 equals -4.9 t squared plus 14t, 5 minus 16, or 5 minus 16, yeah, it's going to be -11. So this is our new quadratic function right here, and we're going to find the discriminant of that new quadratic function. So our a equals -4.9, our b equals +14, and our c equals 11. We're going to plug that into the discriminant formula, figure out what our discriminant is, and we're going to see if it actually exists or not. So b squared is 14. Oh, sorry, it's 14 squared. 14 squared minus 4ac, or 4 times -4.9, and times, that's supposed to be -11 right there, and you can write that, sorry about that. So c equals -11, so 4 times -4.9 times -11, and that's going to give us, if you solve it out, a -19.6. So our discriminant is -19.6, and we see our discriminant is actually negative. And if our discriminant is negative, that means our solutions are imaginary or it doesn't exist. So in that case, we can say that no, the ball does not reach a height of 16 meters. And that's because if it's imaginary, the solutions just don't exist. 35, we're given the number -8 plus 5i. We need to identify the real and imaginary parts, and then we're going to tell whether the number belongs to each of the following sets: real numbers, imaginary numbers, and complex numbers. So the real part in this problem is -8, and the imaginary part is 5i. So the number -8 plus 5i belongs to which of these? It belongs to which of these parts? And it's going to be complex numbers, right? Complex numbers includes everything, and we see we have an imaginary part, so it's not going to be real numbers, and we have a real part, so it's not going to be just imaginary numbers, right? So our only problem, or only solution we have left is the last one, which is complex numbers. 36 through 38, we're going to be doing this by completing the square. So what we want to do is we want to isolate the first two terms and take out that 3. So we can do 3x squared plus 4x plus some blank, and we have plus 15 minus some blank. Not supposed to be parentheses there, and all that's going to equal 0. Okay. From here, what goes in the blanks would be b divided by 2 squared. So 4 divided by 2 is 2. 2 squared is 4. And what goes in the other blank is going to be what you put in that blank multiplied by your a, which you took out. So 4 times 3 is 12. So we end up getting 3. You can factor this out to x plus 2. All that squared of 15 minus 12 is positive 3. All of that equals 0. And we're going to say whether the solutions are real or not. We're going to go ahead and solve it. Minus 3 over. And we get 3x plus 2 squared equals negative 3 divided by 3. We get x plus 2 squared equals negative 1. And then we're going to take the square root of both of it, of both sides. So we get x plus 2 equals plus or minus the square root of negative 1, which is just I. Right? And then you minus the 2 over, that'll give you your solution. So our number of solutions is still going to be 2 since it's non-zero. As long as our solution is non-zero, you're going to have 2 of them. Our solutions are going to be minus that 2 over, like I said. You get x equals negative 2 plus or minus I. And that's where our 2 solutions are going to be. And is it real or non-real? We see we have an I, so it's going to be non-real. We have an imaginary number. It's not going to be real. Okay? You do the same thing for 37 and 38. It's very similar. Just isolate the first 2 terms, factor out your A if you need to, and go from there. Okay, so we're going to solve the following quadratic equations using the quadratic formula, and we'll get exact answers, and we'll simplify and rationalize when possible. Okay, so for 39, we know our A is negative 2, our B is negative 4, and our C is negative 6. We're going to put that into our quadratic formula. So it's negative B, so 4 plus or minus the square root of B squared, or 16, minus 4 times our A, which is negative 4 times negative 2, which is going to be negative 8 times negative 6, which is positive 48. So we get 48 all over 2a. 2 times negative 2 is negative 4, right? So 16 minus 48, that gives us a negative 32. So 4 plus or minus negative 32 all over negative 4. Okay? So we're going to keep going. From here, we can simplify that square root. So we have 4 plus or minus 32. We can factor that to 2 and 16, 4 and 4. So you can take out that pair of 4 right there. So you get 4 root 2 all over negative 4, right? And we see we have 3 4s here, so we divide all 3 4s by negative 4 to get rid of the denominator, and we end up getting negative 1 plus or minus root 2 as our answer, right? And our number of solutions, we see our discriminant is non-zero, so we know our number of solutions is going to be 2. Our solutions are going to be negative 1 plus or minus root 2. And is it sorry, I put the negative here actually, so let's take a step back to our answer. So we have 4 plus 4 square root of negative 2 all over negative 4. Divide the coefficients of 4, the 4, and the negative 4 all by negative 4. We get negative 1 plus or minus the square root of negative 2, which is the same thing as negative 1 plus or minus I root 2. So same thing, our discriminant is still non-zero, so we still have 2 solutions. Our solutions are going to be negative 1 plus or minus I root 2, and our solutions are going to be non-real. We have that I, so we know it's going to be non-real. I'm sorry about that little mistake. Don't forget to bring down your negatives to make sure you get the right answer. Okay? So 40, you do the exact same thing. Just figure out your A, B, and C, put it into your quadratic formula, solve it out, give us the exact answers, and simplify and rationalize when you can. And for number 41, we're given a number negative 3 minus 14i. Identify the real and imaginary parts, then tell whether the number belongs to each of the following sets: real numbers, imaginary numbers, and complex numbers. The real part for this is negative 3. The imaginary is negative 14. And the number negative 13 minus 14i belongs to complex numbers. Once again, we talked about this earlier. We have a real and imaginary part, so it can't be real numbers and it can't just be imaginary numbers. It has to be complex numbers. Okay? If you want the step-by-step solutions, we do have the solution key posted online for all the answers, for all the questions. So you can take a look at that and double check your answers. Other than that, guys, good luck.